Hello, welcome back. This one's for my geometry students. We're continuing our series on proofs. So if you're looking for more work on proofs, check out these links. And now let's take a look at today's. Okay, so let's check out what we're looking at today. So we've got this triangle. We've got another triangle in it. We've got a line here. So we see lots of possibilities for different triangles. Now let's check out what we were given. AF, it's right here, is the perpendicular bisector of BC. All right, well, let's put into the picture that information. Perpendicular means that it hits this at a right angle. Bisector of BC means that it divides this into two equal segments. So there's a lot of information right there. All right, now we have that segment AB right here is congruent to segment AC right there. And so that shows us that that whole big side is congruent to that whole big side. And again, already I'm seeing some possibilities. If I trace around what's involved with those things, I see I have a right triangle and I have, actually, sorry, that mark should be different because those aren't there. I have a hypotenuse and I have a leg. So I have triangle congruence right there. So now let's check in with what we're supposed to prove. Oh no, we still have more givens. D is the midpoint of AB. Okay, so that means that this guy equals this guy. And then E is the midpoint of AC. And so that means, now again, here, let's put this together. If this equals this, then half of this equals half of that. So I can use the same marking. All right, and now I've digested all of my givens and I put it into the picture. So now let's see where I'm going. I need to prove that DF, this guy, is congruent to EF, this guy. All right, the question I always ask is, what is the thing I'm trying to prove involved in, right? So what is this part of? So if I look at DF, all right, well, it's part of this triangle right here. It's also part of this triangle right here. And then it's part of this triangle right here. So I have lots of possibilities. And then EF, same thing. It's part of this triangle right here. And it's also part of this triangle right here. So again, I have many, many possibilities. So I see two ways forward. So I think actually let's do this guy twice. All right, the first way I see forward is if I look at DF as being part of this triangle and EF as being part of that triangle. I see that I've got side, I see that I've got side, and gee, wouldn't it be lovely if I had angle? Well, what are these angles part of? They're part of that big triangle there, which happens to be isosceles. So I do, in fact, have that. So let's write up that proof, and then let's do it again and follow a different line of thought. Okay, so for that proof, I'm going to start by saying that AF is the perpendicular bisector. AF is perp bis, and that was a given. And what I want to take from that is that BF is congruent to FC. And the reason for that is the bisector part of things. We actually don't even really need the perpendicular part. So that would be the definition of bisector. All right, so there's the first bit. Okay, then I'm going to use this information that my larger two sides are congruent, right? AB is congruent to AC, and that one was a given. And then I want to name the fact that these are midpoints, right? D is midpoint of AB, and E is midpoint of AC, and both of those were given. And so that means that AD is congruent to DE, is congruent to AE, is congruent to EC. all of those are equal to each other. AD is congruent to DB, which is congruent to AE, which is congruent to EC, and that's the definition of midpoint, and that's also that 1/2 of equal sides are equal. And so that lets me know that BD is congruent to EC, so I've got that in there. And then finally, I want to say that angle B is congruent to angle C, and that is because angles opposite equal sides are equal. We could also do that by naming this triangle as isosceles and then saying that's the definition of isosceles. And so now I have that triangle DBF is congruent DBF to CEF, and that was because of side, angle, side. And so finally, DF is congruent to EF because of CPCTC. Now, let's take that again and go in a different direction, show you that there are many ways to get to the same place. So the last time we did this, we looked at this triangle and we looked at this triangle because that's what we saw. Let's say instead we wanted to look at this triangle and this triangle. Well, we know that this side is going to wind up equaling this side, right? Because we do the thing of that this is equal to this, and this is the midpoint, and so then all 4 of these segments are equal to each other. We also can prove that if this is the perpendicular bisector, that this whole triangle equals this whole triangle because of hypotenuse leg. And so that will give us that this angle is going to be congruent to that angle. And then finally, we have a reflexive side right there. And so side, angle, side, side, angle, side shows me that this triangle is congruent to this triangle. And then CPCTC shows me that those guys are congruent. So let's go ahead and lay that guy out. All right, so the first thing we're going to do perhaps is we're going to prove that this triangle equals this triangle so that I can get those 2 angles by CPCTC. So I'm going to start by laying out that AF is the perp bisector, and that was a given. And then that's going to show me that angle AFB and angle AFC are both 90-degree angles. They equal each other in their 90-degree angles, and that's the definition of perpendicular bisector. And then we also know that BF is congruent to FC, and that's also the definition of perpendicular bisector. And then finally, we have our given that AB and AC are congruent. It was a given. And so we have now just shown that triangle AFB is congruent to triangle AFC because of the hypotenuse leg theorem of triangle congruence. Okay, which then tells us that angle BAF is congruent to angle CAF because of CPCTC. All right, so I've got my first angle. Okay, so now I'm going to say that AF is congruent to AF, and that's the reflexive. And now finally, I need to get this side here. So that's where I'm going to lay out our midpoints here. So D is midpoint of AB, and E is midpoint of AC, and both of those are givens, which means that AD is congruent to DB, which is congruent to AE, which is congruent to EC, and that is the definition of midpoint, and half of equal sides are equal. And so now finally I can say that triangle DAF is congruent to triangle EAF because of side, angle, side, and that side DF is congruent to side EF because of CPCTC. So you can see same picture, same givens, same result, two different ways of getting there. So all of that is to say that there are many ways to make it through a proof, and some of it is going to be what tickles your mind first and what appeals to you as the easiest path through. All right, so play with those. If you're wanting more proofs, go ahead and check out these links and stay tuned for even more. And meanwhile, keep on mathing.